Alright, this is the third and hopefully final part of this lesson as we continue to talk about graphing rational functions, but we will be talking about finding all asymptotes, vertical, horizontal, and slant asymptotes, as well as any holes in the graph. In the previous video we learned that you will get a hole in the graph anytime you have what would have been a vertical asymptote, except for it cancels out with another factor in the numerator. Alright, in that case there is no vertical asymptote there, but it's still an illegal value, so it just creates a hole in the graph like this. And we're going to see some of those in this lesson. Okay, take a closer look at number 7. Okay, we need to factor so we can see what we're dealing with. Alright, some of us, bless our hearts, and we never did learn how to factor. So you get another chance right now. So this, the numerator, alright, I see it's a trinomial, there's no common factor. Let's go ahead and try to factor this as a binomial times a binomial. Now 3x squared can only factor as 3x times x. 2 can only factor as 2 times 1. Though maybe the 2 should go over here and the 1 should go here. We'll find out in a second. How will we find out, you say? Well, like we used to say over and over and over again. The inner plus the outer has to equal the middle. Inner, I have 2x right now. Outer, I have 3x. Okay, the middle I'm trying to get is a positive 1x. Can I get a positive 1 out of a 3x and a 2x? Sure, if I do a positive 3 and a negative 2. Okay, so the negative 2 would be this right here. The positive 3 outer will happen if this is positive. Okay, will that give me negative 2? Yes, negative times a positive is a negative. So we have now officially factored this correctly. Alright, so we're kind of done with that for now. Now let's see if we can do the same thing with the denominator. Okay, 3x squared, once again, can only factor as 3x and x. 2, once again, can only factor as 2 times 1. Alright, or maybe the 1 goes here and the 2 goes there. We are trying to get a middle of negative 5x. Right? And inner plus outer has to equal middle. Inner, I have 2x right now. Outer, I have 3x right now. I'm trying to get a middle of negative 5. Is there any way I can get negative 5x out of a 2x and a 3x? Yes, if they were both negative. That would be negative 5x. That means both of these would have to be negative. Okay? Will that give me a positive 2? Yes, a negative times a negative is a positive. So this is now factored correctly. So now that everything's factored out, let's step back and see what we're dealing with. Okay? Now, vertical asymptotes. Normally we just set the denominator equal to 0, but we have to watch out for things that cancel out. Okay, because if any vertical asymptotes cancel out, then it won't be a vertical asymptote. It'll be a hole there instead. So because these cancel out, the 3x minus 2's cancel out. Okay, there will be no vertical asymptote right there. So here's what I do have though. So let's talk about vertical asymptotes. I will get a vertical asymptote from the x minus 1. So if I set that equal to 0, that's going to give me x equals 1. So there is one vertical asymptote. Okay. Now, because this factor canceled out, it's going to give me a hole. So let's be real careful. Alright, I'm going to have a hole at something. Now, let's go ahead and set this equal to 0. So if I take that 3x minus 2, alright, off to the side somewhere where I got lots of room. If I set this 3x minus 2 equal to 0 and solve, so adding 2 to both sides, that'll give me 3x equals 2, dividing by 3 on both sides, that gives me x equals 2/3. Alright, so that is the x value of my whole. So I will have a whole at 2/3 comma something. Okay, and we'll come back and figure out what that y value is in a second. Now look, here's how you can figure out what the y value is. Let's go ahead and get it done now. Now that once you cancel these out, then the function would become, if you cancel these out, the function would become x plus 1 over x minus 1. Okay, so what I can do is I can put this in my calculator to figure out the y value at 2/3. Okay, I can use this version to figure that out. So let's see, x plus 1 over x minus 1. Let's get that in the calculator. Hit your table button. I said hit your table button, people. Okay, fraction mode. Alright, so what did I say? X plus 1 over x minus 1. So in the numerator, we have x plus 1. In the denominator, we have x minus 1. Alright? Now, we can either just tell it to start, or we could use the ask feature. It doesn't really matter. Say if we'll use the start thing this time. Okay, 2/3. Now, would that have worked as a fraction? 2/3. Yeah, it's just prettier that way. It's going to go straight to decimal anyway, but whatever, that's fine. We don't care. I'm going to put it back to auto for right now. Okay, so it's starting right there at 2/3, and you see the y value is -5. Okay, so at 2/3, the y value is -5. So that tells us that we have a whole at 2/3 comma -5. Alright, so when we graph this, well, we won't be graphing this one because that's not part of the directions, but if we were to graph this, we would use this point as one of our points to help us graph, but we would graph it as like an open circle. Alright, so fine. So we have one vertical asymptote, we have a whole. Okay, do we have a horizontal asymptote? Let's see. Yes, we will have a horizontal asymptote. Remember, horizontal asymptote is all about the degree. If the degrees are the same, like they are here, what happens? Okay, remember, when the degrees are the same, that's when you use the leading coefficients. Okay, so for my horizontal asymptote, I'm going to get that by doing y equals leading coefficient over leading coefficient, right? So that's going to be y equals 1 will be my horizontal asymptote. So let me just put it up here with the others. Alright, so I have a horizontal asymptote, y equals 1. So I have a horizontal asymptote, a vertical asymptote, and a whole. Will I have any slant asymptote? No, you're never going to have a horizontal asymptote and a slant asymptote. It's either one or the other, because the slant asymptote only happens when the top degree is bigger by 1. And if that happens, then there is no horizontal asymptote, so it's one or the other. So that's it for number 7. For the directions, we were just supposed to find the wholes and asymptotes for each function. So these are the asymptotes and the whole. Alright, let's take a look at number 8. Okay, again, we need to factor the numerator to see if anything is going to cancel out. Alright, like right now it's looking like, oh, maybe there's a vertical asymptote at 2. Well, not so fast. If this winds up canceling out, it won't be a vertical asymptote. It'll be a hole instead. Okay, so this is going to factor. So this numerator should be easy to factor. X squared is x times x. 6, yeah, is it, it's 2 times 3. That's not going to give me a 4 or anything. Yeah, because inner, outer, that's not going to make a 4. How about 6 times 1? That's not going to make 4 either. So that means this is actually unfactorable. So that means this is unfactorable. So nothing's going to cancel out with this x minus 2 or anything. So I will have a vertical asymptote. So let's just go ahead and get that started. So setting this denominator equal to 0, I will have a vertical asymptote at x equals 2. Okay, fine. And if nothing's canceling, there won't be any holes. No holes. And maybe I'll just write that down. Like holes. No. Now, how about a horizontal asymptote or slant asymptote? Well, the top degree is 1 higher than the bottom. So that means I will have a slant asymptote. How do I get it? I divide. So let's do that off to the side. Because it's a nice linear binomial, I can use synthetic division to do it. Alright, so setting this equal to 0, basically, using this right here, it'll be a 2 that goes in the little box. My coefficients are 1, -4, and 6. Okay, 1 times 2 is 2. That makes -2. -2 times 2 is -4, and that's 2. Alright, so putting my variables back in, that gives me x minus 2. So that's why I will have a slant asymptote at y equals x minus 2. Alright, and that's it. That's the answer number 8. We have a vertical asymptote and a slant asymptote. Alright, but we have no holes. Okay.